In this video, I'll show you how to use OpenOffice spreadsheet to calculate the average, standard deviation, and percent error of scientific measurements. Assume we collected 4 data points, 2.0, 1.0, 4.0, and 3.0. How do we calculate the average? Very simple. Type equal sign, and then average, parentheses, A2 colon A5. This will include all 4 data points. And then write parentheses. Hit enter. 2.5. That's the average of the 4 data points. Also, we can calculate the sum of these 4 data points and then divide it by 4. So it's done right here. Equal sign, sum, parentheses, A2 colon A5. That will include all 4 data points. And then divided by 4. So you get the average in a different way. How can we calculate the standard deviation of these 4 data points? Use this function, stdev. So type equal sign, and then function name, stdev, standard deviation, parentheses, A2 colon A5. Hit enter. You get 1.3. So really, this 4 data points give you an average of 2.5 and a standard deviation of 1.3. You can also write 2.5 plus minus 1.3 as the average and standard deviation for these 4 scientific measurements. Again, these 2 are the equations, but I put them in double quote. How can we calculate the standard deviation in a different way? Well, it's simple. We need to first calculate the difference between individual data points and the average. So this is x minus the average of x. So it's A2 minus $8. A2 is the first data point. $8 is over here, the average. So you need to calculate the average first. Why did I put a dollar sign in front of 8? That will help us to fix this number 8. So you'll see. I can drag it down now. And then this one is A3 minus $8. This one is A4 minus $8. This one is A5 minus $8. So you can see it becomes A2, A3, A4, A5, but the $8 is always $8. What if I get rid of this dollar sign and then drag it down? All right, you'll get wrong result. Okay, so for example here, it's trying to minus A9. This one minus A10. This one minus A11. So be very careful here. Put a dollar sign here. And we will hold this 8 unchanged. All right, so that's the difference between the individual data points and the average. And then we need to square those. So over here, equals B2 caret 2. That means this number squared. And then over here, I can just drag it down. So let me delete these 3 numbers. Delete. All right, and then I click this number and look for the bottom right corner. There's a very small filled square. Click that and drag it down. And now I got the squared value of the difference. And then how can we calculate this standard deviation? All right, the equation is here. We first get the sum. So over here, the sum of this column from C2 to C5. The sum of the squared values of the difference between individual data points and the average. And then divide this sum by 3, not 4. Divide the sum by the number of data points minus 1. So if you have 4 data points, divide by 3. All right? And then after that, take the square root of the result of this division. And then you get this standard deviation. All right, so supposedly this number is the same as this number. They are just being displayed with a different number of sig figures. So you can easily change the number of sig figures by right click, format cells, find number, and then change the decimal places to 1. Alright, so over here. And again, this and this show you how to enter the equations. But of course, you need to remove the double quote. Alright, so you can just copy here. And then I'm going to paste here. And then over here, I will delete the pair of double quotes. And then I get this standard deviation again. Alright, how do we calculate the percent error? If you have the literature value, let's assume it's 3.3, how can we calculate the percent error of your scientific measurements? We will have to compare your average value over here with the literature value. So this is what we do. Equal A8, that's your average, minus B12, that's the literature value. Or sometimes it's called a true value. So your value minus true value, and then divided by true value. That will give you the percent error. So I'm going to hit enter. All right, so actually, if you want to display this in a different format, you can do so. I choose percent here, but you can choose some other format, some other decimal places, different number of leading zeros as well. Okay, so if I just enter this function, okay, by the way, you can see the function over here. So I can copy this function, and I'll just put it somewhere else, maybe here. I'll paste. See, this is the percent error in a different format. And again, you can right click, click format, find percentage, and let's look at this decimal places, change it to 0, click OK. Now you have negative 24%. So the percent error of your scientific measurements is negative 24%. I intentionally kept only 2 sig figures here because if you look at all these numbers, they have 2 sig figures. So in conclusion, I feel like negative 24% is not very accurate. And also, if you look at the standard deviation, is this 1.3 is also fairly big. So imagine you have a range, which is from 2.5 minus 1.3 to 2.5 plus 1.3. You have a fairly wide range, so it's not a very precise scientific measurement either. So again, if you look at the percent error, it's not very accurate. If you look at the large standard deviation, it's not very precise.